Hi there. For this video, we will be simplifying logarithms. But first, let us recall some important things in logarithms, specifically the laws of logarithms. So as you can see in the screen, here are the 4 laws of logarithm. First, when we have a product out here, mn, the outcome can be split into the logarithm of m with respect to base a plus the logarithm of n with respect to base a. Next, if we have a quotient out here of m over n, or a fraction, it can be split into the logarithm of m with respect to base a minus the logarithm of n with respect to base a. So it's similar to the first one. Then for the third one, if we have the logarithm of n raised to m out here, what we can do is we can move this out here. As you can see, it's out here. Then lastly, we have what we call the change of base. If we have the logarithm of m with respect to base n, we can write this one as the logarithm of m with respect to some base over the logarithm of n with respect to some base. But note that the bases here, the a's, cannot be equal to 1. So take note of that one. And we will use these laws in simplifying the examples that we have later on. So take a screenshot of this one or take note of this one as I will move on to the next slide. And also, if you are wondering how we had arrived with these laws, you may check out the previous video as we had some proofs on these laws. There. So let's have our first example. We have here the logarithm of 100 minus the logarithm of 3 with respect to 27 and ln of the cube root of e raised to 5. So first, to solve this one, first note that we can write the logarithm of 100, or rather we can simplify the logarithm of 100 as 2. So why is that? That is because the logarithm of 100 is equal to the logarithm of 10 squared. And recall that when the base out here is missing, that simply means that it must be 10. So by another property, we can cancel the exponent and the log out here and we'll simply have 2. So we've got 2 for the logarithm of 100. And let's copy the others. So we'll be doing this term by term to avoid confusion. Next, if we focus on this one, note that 3 is equal to 27 raised to 1 over 3. So why is that? Well, note that 27 is equal to 3 cubed. So 3 cubed raised to 1 over 3 will simply give us 3. And since 27 out here is already the same as the base of the logarithm, then we know that this logarithm is simply the exponent out here, which is 1 over 3. So we'll have here 2 minus 1 over 3 minus ln of the cube root of e raised to 5. So for the last one, we need to get this one out here. But note that ln is simply the logarithm with respect to base e, and the cube root of e raised to 5 can be written as e raised to 5 over 3. And similar to what we had a while ago, we'll simply, since we have an exponential out here and a logarithm out here, and they have the same bases, they can cancel out and we'll just obtain this. So we've got 2 minus 1 over 3 minus 5 over 3. And we simply simplify this one. We've got 2 and negative 1 over 3 minus 5 over 3 is simply negative 6 over 3 or 2. So 2 minus 2 is simply 0. Therefore, we can conclude now that the given logarithm expression is simply 0. And that is the answer for this first example. There. Let's go on to this next example. We've got 4 ln 3 plus 2 ln squared of 5 minus the logarithm of 10 with respect to base 12 over the logarithm of e with respect to base 12. So as you can see, this logarithm, these terms cannot easily be simplified like how we had in the first example. So this time we'll apply the laws of logarithm. First, note that we can move this 4 out here to the exponent of 3 out here, and same with the 2 out here. So we'll have ln of 3 raised to 4 plus ln of, note that square root of 5 can be written as 5 raised to 1/2 raised to 2. And for the last term, note that we can apply change of base out here since we have the same bases out here. So by change of base, this is simply equal to the ln, or ln, that's wrong, this should be the logarithm of 10 with respect to base e. There. But note that log with respect to base e is simply ln. So it's correct. There. Let's move this one. And now let's simplify these expressions. So 3 raised to 4 is simply 81. Yep. And note that 1/2 times 2 out here will simply cancel out. So we'll be left with 1. So this one in the middle is simply ln of 5. And just copy the ln of 10. And what can we do next? We can apply the first two laws of logarithm. Since we have a plus out here and a minus out here, and we know that all of these are ln's, so basically they all have the same base e, then we can express this one as the ln of, remember when it's plus, what we do is we multiply the number. So we've got 81 times 5. Then this is all over, since when we have a minus sign, it goes in the denominator. which is 10. So now we just simplify this one inside. Note that this one will become 1 and this one will become 2. So we'll be left with the ln of 81 over 2. Or if you want it to be decimal, it is simply ln of 40.5. And this one out here is the answer for this problem. So as you can see, a very large logarithmic expression was simplified into simply a single logarithm, which is ln of 40.5. So that is the beauty of the laws of logarithms. So there. Let's have this one last example. We've got 1/2 logarithm of 225 plus 3 logarithm of 2 minus the logarithm of 12. So how do we solve this? Similar to the second example, we start by moving this one to the exponents of the number inside, the logarithm. So 3 will go over here, and for log 12, we simply leave it out here. So this will become the logarithm of 225 raised to 1/2 plus the logarithm of 2 cubed minus the logarithm of 12. And now let's simplify these expressions inside. So note that 225 is actually equal to 15 squared. So 15 squared raised to 1/2 is simply 15. On the other hand, 2 cubed is simply equal to 8. So with that in mind, we can write this one as the logarithm of 15 plus the logarithm of 8 minus the logarithm of 12. And from here, we can now apply the first two laws of logarithms. So again, we have a plus sign out here and a minus sign out here. And we have similar logarithms or logarithms with the same basis. Therefore, this is just the logarithm of first with a plus sign, we'll have 15 times 8. This is all over on the minus sign out here. So we've got 12 in the denominator. And now we are just left to simplify this expression inside the logarithm. So first, note that let's just try to rewrite this one. So we've got logarithm of 15 can be written as 3 times 5. 8 can be written as 2 times 2 times 2. All over 12 can be written as 2 times 2 times 3. And now let's cancel out the similar factors. So we cancel out the 3 out here. We then cancel out the 2's out here. So we are left with 5 and 2. So this is simply the logarithm of 10. But note that, again, if the index here is missing, then this is simply 10. So we've got the logarithm of 10 with respect to base 10. So what does that mean? Recall that from a property of logarithm, so let's write it out here. if we've got the logarithm of a with respect to base a, the outcome is simply 1. Therefore, this logarithm out here just simplifies to 1. So very nice. And that one out here is the answer. So as you can see, a very large logarithmic expression just simplifies to 1. So a really nice application of the laws of logarithm. And this is actually our last example. But before you go, you might want to try this exercise. So in this exercise, you are tasked to simplify the logarithm of x with respect to base 8 minus the logarithm of x with respect to base 4 plus the logarithm of x with respect to base 2 into a single logarithm. So as a hint, you might want to try and apply the change of base law. So it's the fourth law. So you might want to try that one. As you can observe, the bases of the logarithm out here are all different. So take note of that one, and yeah. Feel free to comment down below your answers and solutions to this exercise out here. And also, please comment down below if you like this format wherein I prepared the slides already, as I think it saves a lot more time than me writing it out during the video. So yeah, hope you enjoyed this one, and that's it, and that's all for this video.